Good day, everyone. Once again, welcome back to my channel and welcome back to my virtual classroom. And for today's video, I'm gonna be talking about the golden ratio. Okay, so the golden ratio is an irrational mathematical constant approximately equals to 1.618803398887 and so on. So this is infinite. The golden ratio is often denoted by the Greek letter P. So P is equal to 1.6180339887 and so on. So this is approximate. Also known as golden ratio, golden section, golden cut, divine proportion, divine section, mean of PDIAS, extreme and mean ratio, medial section. So two quantities are in the golden ratio if the ratio between the sum of those quantities and the larger one is the same as the ratio between the larger one and the smaller. So let's take this as an example. So say for example, this length is A and the other one is B. So we have to get the sum, so A plus B, and then divide this by A. So this is equal now to A over V, and that is equal to P. And you know already the equivalent of P as I discussed earlier. So P is equal to 1 plus the square root of 5 over 2, which is equal to 1.618 and so on. For this approximately 1.618 as the golden ratio. One interesting thing about P is its reciprocal. So take note of this, that 1 over P is equivalent to 1 over 1.618, or that is equivalent to 0.618 and so on. So it's highly unusual for the decimal integers of a number and its reciprocal to be exactly the same. A golden rectangle is a rectangle where the ratio of its length to width is the golden ratio, and that is whose sides are in the ratio of 1 is to 1.618. So when the ratio of its length to width is the golden ratio and the shape is rectangle, we call it a golden rectangle. The golden rectangle has the property that it can be further subdivided into two portions, a square and a golden rectangle. This smaller rectangle can similarly be subdivided again into another set of smaller rectangle and smaller square. And this process can be done repeatedly to produce smaller versions of squares and golden rectangles. And because of this, the golden spiral was, of course, discovered. So this is an example of golden rectangle. So if you're going to look at the shape, so the shapes are the same from the smallest to the biggest, and it keeps on repeating, and the size just keep on getting bigger, but it's reciprocal, but it's proportional. So now, um when does the golden spiral came out? So start with the smallest one on the right. On the right, connect the lower right. So say for example, this is the smallest rectangle. Connect with with the corner to the upper right corner with an arc that is 1/4 of a circle. Then continue your line into the second square with an arc that is 1/4 of a circle on that is 1/4 of a circle. Then we will continue this process until each square has an arc inside of it. So look at this one. Each square has an arc inside of it. With all of them is connected as the line continue. So the line should look like a spiral when we are done. So that's why golden spiral was born. Okay, so it's here. So by connecting the corners. Okay. So next we have the golden triangle. So the golden triangle is a special isosceles triangle, and the top angle is 36 degrees, while the bottom two angles are 72 degrees angle. So this is an isosceles triangle because it has two equal sides. Okay, now, what is the relation between Fibonacci sequence and the golden ratio? If you're going to look at this, the Fibonacci sequence, going back to the Fibonacci sequence, so 1, 1, 2, 3, 5, 8, 13, 21, 34, and 55. So notice that as we continue down the sequence, the ratios seem to be converging upon one number. And while it is becoming, we continue getting the ratio, while it's getting, the ratio becomes or getting smaller until such that the ratio now are the same. So look at this, 2 over 1 is 2, 3 over 2 is 1.5, 5 over 3 is 1.67, 8 over 5 is 1.6, 8 over 13 over 8 is 1.625, 21 over 13 is 1.615, 34 over 21 is 1.619, so it's bigger, and then 55 over 34 is 1.618, and 89 over 55 is 1.618. So look at the last ratio. So as you go through, the ratio now becomes equal or the same, or it gets getting smaller. Okay, if we continue to look at the ratios as the numbers in the sequence gets larger and larger, the ratio will eventually become the same number, and that number now is the golden ratio. So look at this. As you get the ratio of the numbers, you'll see that the ratio now eventually become the same number. Okay, so if you're going to reduce it or round it off, so now that is what we call the golden ratio. That's why the golden ratio is 1.6180033 and so on. Okay, so now let us see the application, or let us see the golden ratio in nature as it happens. Okay, we have an example, Nautilus shell. So it shows golden ratio, of course, with the golden spiral. Okay, so golden ratio in art also. Many artists who lived after Phidias have used this proportion. So Leonardo da Vinci called it the divine proportion and featured it in many of his paintings. So say an example is Mona Lisa's face is a perfect golden rectangle. Why? Look at the picture. So according to the ratio of the width of her forehead compared to the length from the top overhead to her chin. So it's proportional. So what about golden ratio in the human body, or we call it sometimes as happy measurement. Okay? So golden ratio in fingers. So look at this. So that means each of these carpals are proportional to each every bone structure found in your fingers. Okay? So golden ratio in fingers. And also this one, your palm is proportion to this one. Okay, so it the golden ratio of 1.60 and so on. Okay, and of course the golden ratio in the face. So the blue lines, look at the picture. The blue line defines a perfect square of the pupils and outside corners of the mouth. So the golden section of these four blue lines defines the nose, the tip of the nose, the inside of the nostrils, the two rises of the upper lip and the inner points of the ear. The blue line also defines the distance from the upper lip to the bottom of the chin. Okay, the yellow line is a golden section of the blue line, defines the width of the nose, the distance between the eyes and eyebrows, and the distance from the pupils to the tip of the nose. The green line, a golden section of the yellow line, defines the width of the eyes or the eyes, the distance at the pupil from the eyelash to the eyebrows, and the distance between the nostrils. And the magenta line, a golden section of the green line, defines the distance from the upper lip to the bottom of the nose and several dimensions of the eye. So this is the golden ratio in the face, or we call this happy measurement. If you still remember, sometimes you don't bring a tape measure when you're buying pants or shorts. Where did you measure it? On your in around your neck, because your neck is proportional to your waist. So the front two incisor teeth from a golden rectangle with a P ratio in the height to the width. The ratio of the width of the first tooth to the second tooth from the center is also P, or 1.6018. The ratio of the width of the smile to the third tooth from the center is P as well. And of course, this one, the last one, the golden ratio in the human body. So look at the picture. So the white line is the body's height. The blue line, the golden section of the white line, defines the distance from the head to the fingertips rather. The yellow line, a golden section of the blue line, defines the distance from the head to the navel and the elbows. The green line is a golden section of the yellow line, defines the distance from the head to the pectorals and inside top of the arms, the width of the shoulders, the length of the forearm, and and the shin bone. While the magenta line, a golden section of the green line, defines the distance from the head to the base of the skull and the width of the abdomen. The section portions of the magenta line determine the position of the nose and the hairline. So although not shown, the golden section of the magenta line, also the short section of the green line, defines the width of the head and half the width of the chest and the hips. So we also call this as happy measurement. Okay, when we're in elementary, our teacher taught us happy measurement. We use our body parts to measure something, and it's directly proportional to the other parts of the body. So I hope you learned something today. Please do not forget to subscribe to this channel and share it to your friends. So thank you so much, and thank you for watching.